In this video, I'm going to tell you how clouds are going to form. We're also going to talk about the type of clouds that are out there. We'll also talk about why precipitation occurs. So to start, let's talk about the steps in cloud formation. Clouds are formed by warm air being forced upward. This is step one. We know that warm air is going to rise because it's less dense. So warm air will be forced upward. Moist air, remember, is lighter than dry air, so most of this warm air will probably have some moisture in it because these two things go together. Once that warm air gets higher in the atmosphere, we know that as elevation increases, temperatures will drop. As that warm air expands, it will get cooler and it will eventually cool to the dew point. This is step two. So again, our first step was that warm air was being forced upward, so warm air rises. Our second step is that warm air now is expanding and cooling to the dew point. Now, when we cool to the dew point, remember, water vapor will condense into water droplets, or we have a step going from gas to liquid through condensation. So this is step three. Once we've reached the dew point, condensation will occur. So now again, we have warm air rising up because it's less dense. We have warm air expanding and cooling to the dew point. And when it reaches the dew point, step three, that water vapor, or the gas form of water, will condense into water droplets of the liquid form of water. Now, droplets are really small, so they will remain suspended in the air, and they're going to form around dust particles and other particles in the air, okay? So these droplets are going to attach themselves to things to remain suspended in that air. So this is step four. But one thing we want to add to step four is that these particles that are formed, they're attaching themselves to in the air, these particles are called condensation nuclei. Okay, so if you want to just make yourself a little note here, that dust particles, any kind of particle that's up there, maybe some pollen, anything like that, that water can attach itself to, that is going to be what those droplets attach to. Once those water droplets attach to those things, they're suspended in the air, and that's what we see as a cloud. Okay, so our four steps to cloud formation are, once again, warm air rises. Once it rises, it expands and cools to the dew point. It then at the dew point, the vapor condenses into droplets, and then the final stage of cloud formation is when these water droplets attach themselves to things called condensation nuclei, which is dust or pollen or anything up there that they can attach themselves to. They will remain suspended and a cloud is forming. Okay, so you might want to fill that in on the side here. Those are the steps of cloud formation. Now at the surface, we can see instead of attaching to dust particles, they can actually attach to grass. Okay, so if these droplets attach themselves to grass, that would be known as dew. You can sometimes see droplets attaching themselves to your glass or your soda can, okay, from that condensation. Or, you know, if the temperature is not warm enough for dew, that's also frost, okay? So billions of droplets have to be there to form a cloud, so that it's not just a couple of droplets, there's a lot of droplets. And it doesn't necessarily have to be water droplets. We can see that depending upon where you are in the atmosphere, if the dew point is less than 0, so you're higher up in the atmosphere, ice crystals will sublimate. And sublimate is going from a gas, so our vapor phase, to a solid, which would be our ice crystals. Okay. Now, these droplets will be suspended in the air until they're heavy enough to fall. So that's a really big thing there. Heavy enough to fall means that now we're going to have precipitation. Okay? So there's something called the cloud base level, also could be called the lifting condensation level, or the LCL. This is where clouds begin to form. So this is really important. Okay, so we're going to be asking you to find the cloud base level, and this is just on a particular day and time where are the conditions appropriate for these clouds to form. So if you remember in our steps of cloud formation, we have to reach the dew point. So when we reach the dew point, that's when our relative humidity is 100%. So air temperature equals dew point. So let's look at this chart here. At the surface, if this was a specific day, surface temperature was 92, dew point is 60. We're not reaching, air temperature is not reaching dew point, so relative humidity is not 100%. So we're not going to have clouds form. You have to reach the dew point for a cloud to form. Step 2 here is that temperature is 76 at 3,000 feet. Dew point's still 60, so temp and dew point aren't the same, so we're not going to have clouds form. Here at 6,000 feet, temperature and dew point are equal, okay? So you'll notice clouds are forming because in order for a cloud to form, temperature and dew point have to be the same. So the cloud base level, or this LCL, would be at 6,000 feet in this diagram, and this is just where clouds can begin to form or where your temperature is met your dew point. So if you are going to have a cloud on the surface, remember, temp and dew point would have to be the same, and that would be known as fog. Okay, and I'm sure we've all seen fog before. The next thing your notes ask you to do is to fill in this chart, and we also have to use page 12 of our reference table to fill out the data table below, okay? You can, if you remember, if you need to watch previous videos, dew point and relative humidity, that's page 12 of your reference table, so you can go ahead and fill those out. But in this video, I'm only going to show you how to find this, the cloud base level, okay? So again, you're going to need your dry bulb temperature and your wet bulb temperature. Remember, your dry bulb temperature is your regular old air temperature. Your wet bulb temperature is the temperature at which evaporation occurs, okay? And we're going to use these things along with our dew point, okay, to actually determine the cloud base level. So if you want to pause the video right now and use page 12 of your reference table to find the dew point, and then we'll come back so we can do an example together. Okay, so these are the dew points that I got. Hopefully you got the same. If not, you want to make sure that you make a note to ask about that. But what we're going to use here for the cloud base level chart is our dry bulb temperature, which is our regular air temperature, and we're going to use the dew point. Okay, so these are the two columns we're going to use. So for our first example, we're going to use 14 and 6, okay? So on this chart here, you can see they're telling you the temperature is the solid lines, the dew point is the dashed lines. And where your two lines meet are going to be the cloud base level. Okay, so our temperature was 14 degrees. So what we're going to do is we're going to go to temperature 14, and notice how the solid lines are diagonal. So we want to follow the solid lines across, so I'll just follow this up. 14, whoops, was our line, and you could do it all the way up if you wanted to. And then our dew point is these dashed lines, and our dew point was 6. So what we're going to do is we're going to start at 6. We're going to follow the dashed line all the way up, and then wherever our two lines meet, which is right in this position, we're going to read over to either side, and we're getting a value in between these two lines here. Which would be, if you notice, this is 0.5, so this is 0.6, 0.7, 0.8, 0.9, or 1. So it's in between there. So you could put 0.95 kilometers. Or if you just wanted to write about 1 kilometer, that would be fine. So what we just found here was the altitude in the air of where a cloud would be forming, or where we would have reached our dew point, or our temperature would have reached our dew point, which means we have 100% relative humidity, so water vapor can condense to water droplets. So go ahead and try the rest of these. We will be doing a station with this chart today in class. Last thing we want to tell you about is the types of clouds. Clouds are classified by their form and their height, okay, and their shape and their height may vary based upon temperature, pressure, and the amount of water vapor. So if you think back to the way clouds form, that's really going to affect actually the shape and the height of them. Okay, so there's three main forms: cirrus, stratus, and cumulus. Cirrus clouds are these wispy clouds up here. They're really high in the atmosphere. Stratus clouds are like blankets. If you've ever noticed a day when the sky just looks gray, those are stratus clouds. And cumulus clouds are those poofy clouds. Right here's a picture of one that you probably drew when you in a picture in elementary school. Okay, we then attach these words to the height of clouds. So cirro, so you might hear cirrostratus, cirrocumulus. These are clouds that are high in the atmosphere, so typically high clouds are made of ice crystals. Alto means they're hanging out in the middle. They're not high, they're not low. So alto stratus, alto cumulus. And then strato are the low clouds. So you might hear stratocumulus, stratus cloud. Okay, these are all found low in the atmosphere. Okay, so if we look here at these shapes, we can see that here's your strato, here's your cirro, and here's your cumulo. Just some pictures to help you remember that. Very last thing here is if there is a dark cloud, that's actually just showing that it's thick or full of water. So actually, if you went and flew above that cloud that looked gray in an airplane, you would see that it would be white from the top. Stratus clouds have a gentle rain because they're not thick, so thickness tells you how much water vapor there is, which then would tell you what kind of precipitation could be happening. And the air is always cleaner after it rains. That's one of our questions here. We'll talk about that in class. Kind of think about how clouds form and kind of think that through. How is that going to make the air cleaner after it rains? And then the last thing is precipitation. Anytime you see clouds, there's water vapor in the air, so we may have precipitation. This is nature's way of cleaning the atmosphere. So ice crystals or water droplets must come together to become big enough to fall. So here's our real thing we want to remember. Precipitation occurs when those droplets or those ice crystals in the cloud are heavy enough to fall. Okay, so that's when you're going to see precipitation.